Lesson 5.5, Absolute Value Inequalities, Day 1. Our essential question is how do you solve and graph a less than absolute value inequality? So that means we're working with an absolute value inequality that has a less than or equal to symbol in it. All right, we're going to start out by talking about what some inequalities mean, what they mean when they have absolute value bars in them. And so it says, what does each of these inequalities mean? And draw a graph and explain. So for starters, we've got the absolute value of x is less than 4. Well, remember that absolute value means the distance away from 0 on a number line. So we've got the absolute value of x, and it's less than 4. So if you think about what that means on a number line, the distance away from 0 is less than 4. Well, that distance could be moving to the right 4 or moving to the left 4. So what happens is we've got an interval from -4 all the way to +4. And that would represent all of the numbers that are less than 4 units away from 0 on a number line. So from 0, 4 units away, so this is 4 units to the right, or this way, it would be 4 units to the left. So it creates a segment from -4 to +4. So remember that that would mean -4 is less than x, which is less than 4. So we learned in a previous lesson how to write an interval inequality to go with that graph that looks like a line segment. So the distance away from 0, So this would be the same inequality as absolute value of x is less than 4. So this is going to be helpful on our next one. Okay, so now you may notice on the next one, we have not just the absolute value of x, but it's x minus 5, and that distance is less than or equal to 1. So we're not talking about the distance away from 0 on this one. We're actually talking about the distance away from the number 5. So distance away from 5. If that looks a little bit confusing to you, I want you to think about how you would find the distance between numbers. Like, for example, the numbers 10 and 12. If I asked you how far apart they are from each other, you would subtract them. 12 minus 10 is 2. They're 2 units apart. The absolute value bars mean that even if you subtracted them the other way around, 10 minus 12 is -2, but the absolute value bars would turn that distance into 2, +2. Distance is always positive. So the distance between two things is found by subtracting them. My first example just had x, or x minus 0, so it was the distance away from 0. Now we're talking about the distance away from the number 5. And that distance is less than or equal to 1. So 1 unit away from 5 in each direction would take me to 4 and 6. And because there's a line underneath my symbol, my interval is going to have closed circles. So 4 is less than or equal to x is less than or equal to 6 would describe that interval. Okay, one more example, just because sometimes we're talking about the distance away from a negative number. So because this one has an x plus 2, I want to remind you that that would mean x minus -2. So it's actually the distance away from -2 on this one. So distance away from -2 I'm going 3 units in each direction because it's less than 3 units away. So I start with -2. If I move to the right, it would be -1, 0, and then +1. And if I move to the left, it's a little easier, -3, -4, -5. So my graph should have an open circle on each of those and connected in between. So the distance away from -2 has to be less than 3. So less than 3 units away, so there are open circles. So -5 is less than x is less than 1. That would be my interval inequality. Okay, so now to solve and graph, I'm going to show you a different method for solving and graphing these. So you don't have to be able to just draw the graph and write the inequality. You could solve them as the positive case, if you keep the positive on the inside, negative case, negative inside, and then put together your graphs. When the inequality is a less than, that means that it is going to be an interval, so the connecting word that we use is and. So if I solve this first case 1 where I keep what is inside over here a positive, I add 8 on each side, so x is less than or equal to 10. Then if I solve the other one, because remember the opposite, so I've got a negative in front, the opposite of x minus 8, you can do one of two things. You can distribute, if you want to, distribute the negative sign, like this, so it'd be -x plus 8, and then solve it. Or you could divide by that negative that's in front of the parentheses. You could divide by it right away. So I'll show you that on the next example. Make sure you divide by that -1 and flip your symbol so x is greater than or equal to 6. Okay, so first of all I need 6 to 10 on my number lines. By solving it this way, it's very similar to our last section. So it may be a good idea to solve it this way instead of the way that I just explained on the previous slide. So less than or equal to 10 is a closed circle going to the left. Then I've got greater than or equal to 6. So that would be a closed circle going to the right. And because the connecting word is and, because we're talking about an interval, connecting word is and, so if I overlap these, you can see that they overlap starting at 6 and ending at 10. So my inequality would be 6 is less than or equal to x is less than or equal to 10, like that. So inequalities with a less than or equal to symbol represent intersections. If you think about the distance away from, this is saying the distance away from 8 is less than or equal to 2. So the midpoint of my segment is 8. And the distance on each side of 8, it's 2 units away, 6 and 10. Okay, the next one. This one is much more complicated. My first method when I was showing you how you could look at it and figure out the distance away, this is way trickier. So this second method of solving and graphing the two inequalities, this is definitely going to be the way to go on this one, because it's not as simple the distance away from 5. So if I solve the first inequality, I add 5 on both sides, and then divide by 2, I get x is less than 4. I'm going to show you how to solve this second inequality by dividing to get rid of that -1. Dividing to get rid of the -1 right away. So then what happens is I will have 2x minus 5, but I have to remember to flip my symbol, and then 3 divided by -1 is -3. So two things happened. If you want to compare, use my highlighter, if you want to compare this inequality to this one, there were 2 changes that took place. So the inequality symbol flipped from a less than to a greater than, and the 3 changed. to a negative 3. So if you're looking for kind of a shortcut, that would be the shortcut to figuring out your case 1 and case 2. Now I can finish solving this one. I get 2x is greater than 2 and divide by 2. So x is greater than 1. So my number lines need to go from 1 to 4. And remember, we're looking for where they overlap because less than with our absolute value is an intersection. So less than 4, open circle going to the left. And then greater than 1 is an open circle going to the right. So hopefully you can see where these are overlapping each other. If I drag it down from 1 to 4. And on this one, they're both open circles. So that means 1 is less than x, which is less than 4. So, one more to look at, and this is off, so we'll fix this. Okay, so case 1, so inside is positive, so 3x minus 2 is less than or equal to 7. And then case 2 where it's negative, so we have to make it the opposite. Okay, so on my first one, I add 2 on both sides. So 3x is less than or equal to 9. And then divide by 3. X is less than or equal to 3. On my second one, I am going to go with the shortcut. I'm going to divide the negative 1 on both sides to get rid of it. So 3x minus 2 is now greater than or equal to negative 7. So remember, 2 changes. I'm going to highlight that one again just to make sure that you understand this original and this new one, case 1 and case 2. There were 2 changes. Very important. Okay, add 2 on both sides. So 3x is greater than or equal to negative 5. And then I divide by 3. And I am going to get x is greater than or equal to a negative 1 and 2/3. All right, so my number lines, I need to have, let's say, negative 2, negative 1, 0, 1, 2, and 3. Because negative 1 and 2/3 is in between negative 1 and negative 2. Okay, so my red ray less than or equal to 3. And then my blue one greater than or equal to negative 1 and 2/3, so about right here. So where they overlap is going to be starting at negative 1 and 2/3 and ending at 3 and then connected in between. So less than or equal to x, less than or equal to 3, just like that. Okay, so you've seen 3 examples where we figured out case 1 and case 2, we graphed them, and we got our interval, inequality, our graph, and our inequality. So that's what you should expect to see with these absolute value inequalities. If they have a less than or equal to, you should expect to see an interval. You should be able to write a summary now. Make sure that you restate your essential question and use complete sentences.